Midland Asphalt Materials Incorporated, established in 1938, is the leader in liquid asphalt products and application services. Midland has developed a truly innovative pavement preservation system, one that is cost-effective, using a fast application process, that extends pavement life by reducing and delaying reflective cracking, by sealing and enhancing the surface treatment, that increases tensile strength and flexibility, and that has a proven performance record in all types of severe weather while standing up to years of traffic of all volumes. The process is called FiberMat, the ultimate crack-inhibiting, stress-absorbing membrane process. FiberMat is a combination of polymer-modified asphalt emulsion, chopped glass fiber strands, and aggregate. Many hot-mix asphalt pavement overlays prematurely exhibit cracking patterns similar to that which existed in the old underlying pavement. In this instance, cracking in the new overlay surface is due to its inability to withstand shear stresses and tensile stresses created by movements concentrated around pre-existing cracks in the underlying pavement. FiberMat creates a durable membrane that absorbs some of the stresses generated in the pavement structure. FiberMat delays the future onset of cracks by virtue of the glass fiber mesh and sealing of the pavement, providing a waterproofing barrier. Groth Road in upstate New York town of Murray was one of the first North American FiberMat projects. The project was completed in the fall of 2003 with the installation of a conventional CRS 2P emulsion-based chip sealing system on one lane and application of FiberMat Type A on the other lane. The roadway was subjected to extensive and aggressive snowplow operations. After the first 6 months, longitudinal reflective cracks had started to reappear on the regular chip seal side, while no cracks had appeared on the FiberMat side of the roadway. In January 2005, longitudinal reflective cracking and snowplow damage, scalping of the aggregate layer, were evident on the chip seal side, while the FiberMat side was still in very good condition. In January 2006, further evidence of snowplow damage was noted, along with water pumping from the lower layers on the chip seal side, while only nominal slight damages started to occur on the FiberMat side, all the while the membrane itself was still intact. In January 2007, the chip seal side showed significant deterioration, becoming now a candidate for total rehabilitation, while the FiberMat side, after over 4 years, only just started to show minor damage. By summer 2008, the original chip seal side fully deteriorated, with aggregate being lost and the surface raveling along with the aforementioned distresses. The FiberMat system is a completely self-contained unit, housing a significant amount of fiber in the storage area of the main portion of the machine. Spools of fiber feed through tubes into the lower rear portion through a cutter assembly. This area cuts the fibers to a specific predetermined length and at a predetermined rate. Prior to fiber distribution, an initial layer of polymer modified asphalt emulsion is sprayed onto the road surface through a traditional slotted jet bar. The chopped fibers are then distributed on the emulsion surface using an air-blown system. This is then followed by a second layer of polymer modified asphalt emulsion. Aggregate from a chip spreader is then embedded into the fiber-reinforced membrane by rolling to create a robust, stress-absorbing layer.
Well, there's several treatments that could be used here, ranging from chip seals, for example, that would just basically seal and put a cover aggregate on top. But that wouldn't delay really the alligator cracks and the reflected cracks from propagating through again. So that's where the benefits of the fiber come into play. Another is mill and fill. The milling and filling operation obviously uses larger amount of resources than this, not only in terms of the overlay itself, but the energy costs used up in the milling process. Although some of those millings can be used in a recycle manner, it's a lot more cost effective to do everything in situ. And in this case, we're putting the fiber membrane down with the ultra-thin overlay going over the top tomorrow.
The advantages of Midland Asphalt's FiberMat process are clear. Extended pavement life, fast application process, reduces repairs and delays cracking, increases tensile strength and flexibility. No milling necessary. Can be used on all traffic volumes. Bonds well to concrete and asphalt. Economical in terms of whole life cycle costs. Can be recycled at a later date without the risk of large chunks or mesh blocking milling operations or causing problems back at an HMA plant. And open to traffic minutes after completion.
We can open the road up within 20 minutes. You can leave it as the FiberMat Type A, as the reinforced chip seal, or you can actually then overlay it at the same day, within hours, the following day, or in a few weeks' time, depending on the job requirements. This makes the system very, very versatile.
Midland Asphalt strives to add value and concentrate on the environmental impact of our processes to help bring cleaner solutions to our customers. FiberMat achieves this goal by extending the life of the road surface, resulting in fewer materials being used during the road's whole construction life cycle. If you're looking to stabilize, strengthen, and resurface, to add another tool to your preventive toolbox, to inhibit cracking and delay reflective crack propagation, economically, efficiently, and effectively, FiberMat from Midland Asphalt is your solution. To learn more about FiberMat, contact a Midland Asphalt representative.